Hello everyone, welcome to the virtual lab of 90 Plus My Tuition app. We all know about concave lens, right? It is a diverging lens. Take a look here. You can see that a concave lens is thinner at the middle and thicker at the upper and lower edges. We know that we can't display the image of a concave lens on the screen, right? Why is it so? It is because the image formed in a concave lens will be a virtual image. So we can't measure the focal length of a concave lens using direct method. Then we need to use the indirect method to measure the focal length of a concave lens. Are you ready? Okay, then let's get on to our new experiment, that is concave lens. Let us check what is the aim of this experiment. It is to find the focal length of a concave lens using a convex lens. I hope you know that we can easily display the image of a convex lens on the screen. So as to find the focal length of a concave lens, we need to use the convex lens as well, so that we will get the real image displayed on the screen. Now let us get to know the apparatus required for this experiment. Are you excited? Okay, they are the screen, illuminated wire gauze, the meter scale, stand, convex lens of focal length 10 cm, and finally the concave lens. Before we start, let's have a look at the theory required to do this experiment. In this experiment, we use two methods. They are lenses in contact and lenses out of contact. First, let us get to know what is lenses in contact. In the case of lenses in contact, when a convex lens of focal length f1 and a concave lens of focal length f2 are placed in contact with each other, then the equivalent focal length of the combination is given by 1 by f is equal to 1 by f1 plus 1 by f2, or we can write f2 is equal to f into f1 divided by f1 minus f. Next, let us get to know the method lenses out of contact. In this method, the focal length of a concave lens is given by f2 is equal to u into v, the whole divided by u minus v. Here, u is the distance of the concave lens from the virtual object and v is the distance of concave lens from the image. Come, let's see a ray diagram. As you clearly see here, u and v are already marked in the ray diagram. This is how we arrange our apparatus in the experiment. So let's start our experiment. For this, let us place the illuminated wire gauze and a stand in front of it. Now let us fix a convex lens and a concave lens like this on top of the stand as you see here. You can find that the convex lens is facing the illuminated wire gauze here. After that, let us place a screen in front of this combination of lenses. Here, you can observe that the illuminated wire gauze, the combination of lenses and the screen is arranged on a straight line. Now, let us start our experimental procedure. Here, we need to find the image of the illuminated wire gauze on the screen, right? For that, let us fix the distance from the illuminated wire gauze to the combination of lenses as 20 cm. Then let us adjust the position of the screen in such a way that we get a clear image of the wire gauze. Yes, we can see a clear image of the illuminated wire gauze, right? Next, let us try to measure the distance from the combination of lenses to the screen. Here we get the distance as 36 cm. That is, we got the value of u as 20 cm and v as 36 cm. Now let us repeat the same procedure by placing the combination of lenses at a different distance from the illuminated wire gauze. This time let us place the combination of lenses at 22 cm away from the illuminated wire gauze. Further, let us adjust the position of the screen in such a way that we get a clear image on it. Now, once again, let us measure the distance between the screen and the combination of lenses, and the distance comes out to be 30.9 cm. So here we get U as 22 cm and V as 30.9 cm. It's not over yet. Now let us do the same experiment by placing the setup at a different distance. So this time let us place the combination of lenses at 24 cm away from the illuminated wire gauze. Here we can say that the value of U is 24 cm. Now let us adjust the position of the screen in such a way that we get a clear image of the illuminated wire gauze on it. And now we have to measure the distance between the screen and the combination of lenses, and the distance comes out to be 27.7 cm, which is the value of V. So we can say that the value of U is 24 cm and the value of V is 27.7 cm. Well, again let us repeat the experiment by placing the combination of lenses at different distances, that is 26 cm and 28 cm away from the illuminated wire gauze. And now let us record all the values that we got in a tabular form. Now let us look at the table. Here we can see 3 columns. In the first column we have to note the distance between the combination of lenses and the object, that is U in centimeter. In the second column, mention the distance between the combination of lenses and the image, that is V in centimeter. And in the third column, mention the focal length. Now let us fill the first column, which denotes the different values of U, that is 20 cm, 22 cm, 24 cm, 26 cm and finally 28 cm. Further, let us fill the second column, which denotes the value of V, that is 36 cm, 30.9 cm, 27.7 cm, 25.4 cm and finally 23.8 cm. And now lastly we have to fill the third column that denotes the focal length of the combination of lenses. Well, for finding out the focal length, we can use this equation, that is focal length F is equal to U into V divided by U plus V. Note that we have to fill the values of focal length in centimeters. Well, let's start calculating the focal length for the first values, where U is equal to 20 cm and V is equal to 36 cm. And now if we substitute these values in the equation of focal length, that is F is equal to UV divided by U plus V, then we get 20 into 36 divided by 20 plus 36, that is equal to 12.9 cm. So we can write the value 12.9 cm in the third column of the table. Next, if we do the same procedure for the second set of values of U and V, we get 22 into 30.9 divided by 22 plus 30.9, which is equal to 12.9 cm. That is, we got the same value again for the second set of values of U and V. Then what about the focal length value for the remaining cases? What do you think? Will it be the same again? Oh yes, it is same for all the values when we calculate it using the equation of the focal length as you see here. That is, for all the 5 cases, the focal length value is 12.9 cm. Next, we need to calculate the mean of the focal length values. That is, mean focal length of the combination of lenses F is equal to 12.9 plus 12.9 plus 12.9 plus 12.9 plus 12.9, the whole divided by 5, which is equal to 12.9 cm itself, right? That is, we got the mean focal length of combination of lenses as 12.9 cm. Our first aim was to measure the focal length f2 of the given concave lens, right? So let us try to find it out using the indirect method. Then let us use the equation of the focal length of the concave lens, that is f2 is equal to f into f1 divided by f1 minus f. Here f1 is the focal length of the convex lens which we have considered. For this experiment, we have considered the convex lens with focal length 10 cm, right? Then, by substituting the values, let us try to find out the value of f2. That is, f2 is equal to 12.9 into 10 divided by 10 minus 12.9, which is equal to minus 45 cm. Or we can write the focal length of the given concave lens as f2 is equal to minus 45 into 10 raised to minus 2 meter. I hope you know that the focal length value of the concave lens will always be a negative value. Moving on, our next aim is to find the focal length of the same concave lenses by using the next method, that is lenses out of contact. First, we need to know the apparatus required for this experiment. We require illuminated wire gauze, stand, convex lens, concave lens and a screen. Next, let us recall the theory required to do this experiment. Here you can see a needle placed at the point O at one side of the convex lens L1. You can also see that the real and the inverted image I is located on the other side of the convex lens as shown here. Now, placing a concave lens L2 between the convex lens L1 and the inverted image I, we can see that the concave lens diverges the ray and the image is now formed at I'. For any concave lens, I is the virtual object and I' is the real image. Using the equation 1 by f is equal to 1 by v minus 1 by u, we can measure the focal length of the concave lens. That is, the focal length of the concave lens is given by f is equal to uv divided by u minus v. As you saw in the figure shown here, let us try to do the experiment. Let us begin by placing a convex lens at a particular distance from the illuminated wire gauze. Next, let us place a screen at the opposite side of the convex lens and then adjust the position of the screen in such a way that we get a clear image of illuminated wire gauze on the screen. Now, let us take the concave lens of which we have to find the focal length and place it in between the convex lens and screen at a particular distance. Keep in mind that the initial distance taken between the illuminated wire gauze and convex lens should not be altered. Now, we have to measure the distance between the screen and concave lens, and this will be our u. That is, u is the distance between the virtual object and concave lens. Now, adjust the screen so that we would get a clear image of the illuminated wire gauze on the screen, and then measure the distance between the screen and the concave lens as v. That is, v is the distance between the real image and concave lens. In such a manner, by changing the distance between the concave lens and the screen, we can find the focal length of the given concave lens. So, let's start the experiment. First of all, measure a distance of 15 cm from illuminated wire gauze and place the convex lens at that point. Then, place a screen opposite to the convex lens. Here, you can observe that the illuminated wire gauze, convex lens and the screen lies in a straight line. Keep in mind that the distance between the convex lens and illuminated wire gauze should not be changed while performing the experiment. That is, the convex lens should always be at a distance of 15 cm from the illuminated wire gauze. Now, adjust the screen to a position where you will get a clear image of the illuminated wire gauze. Next, we have to measure the distance from the screen to the convex lens. By measuring, we will get the distance as 30 cm. Now, take the concave lens of which we have to find the focal length and fix it on the stand. After that, place the concave lens 15 cm away from the screen in between the convex lens and the screen. Now, we can say that the value of u equals to 15 cm. With the help of this concave lens, adjust the screen to get a clear image of the illuminated wire gauze. Now, let us measure the distance between screen and concave lens, and here it is 22.5 centimeter. That is, we got the value of V as 22.5 centimeter. Thus, here we got the value of U as 15 centimeter and the value of V as 22.5 centimeter. Now, let us remove the concave lens from its position and place the screen back to its previous position. That is, move the screen to the position such that the distance between screen and convex lens is 30 centimeter. Again, take the concave lens under consideration and place it 17 centimeter away from the screen, between the screen and the convex lens. Then we can say that the distance between the screen and concave lens, that is U, is equal to 17 centimeter. Now move the screen to the position where we will get a clear image of the illuminated wire gauze. From there, let us measure the distance to the concave lens. Yes, here we are getting the distance as 27.3 centimeter. That is, here U is equal to 17 centimeter and V is equal to 27.3 centimeter. Again, let us remove the concave lens and place the screen back to its previous position. That is, move the screen to the position such that the distance between screen and convex lens is 30 centimeter. Then place the concave lens between the screen and the convex lens, but at a distance of 19 centimeter from the screen. Now we can say that the distance between screen and convex lens, that is U, is equal to 19 centimeter. Next, let us move the screen to the position where we will get the clear image of the wire gauze. Yes, here we can see a clear image of wire gauze on the screen. Now let us measure the distance from the screen to the concave lens. In this case, we are getting the distance as 32.9 centimeter. That is, here U is equal to 19 centimeter and V is equal to 32.9 centimeter. Now let us try finding the focal length of the given concave lens by repeating the same procedure by making the distance between the screen and the concave lens to 21 centimeter and 23 centimeter. We need to record the values in tabular form. For that, let us consider a table. Here we have columns for recording the distance between the concave lens and virtual image in centimeter, and also for the distance between the concave lens and the real image in centimeter. Let us enter the values that we got in these columns as you see here. Now the last column is for recording the focal length of the concave lens in centimeter. Let us consider the first case, that is U is equal to 15 centimeter and V is equal to 22.5 centimeter. Let us calculate the focal length for this case, that is focal length F is equal to U into V divided by U minus V, that is equal to 15 into 22.5 divided by 15 minus 22.5, that is equal to minus 45 centimeter. So here we got the focal length of the concave lens as minus 45 centimeter. Next, let us consider the second case, that is U is equal to 17 centimeter and V is equal to 27.3 centimeter. Here focal length will be F is equal to UV divided by U minus V, that is equal to 17 into 27.3 divided by 17 minus 27.3, that is equal to minus 45 centimeter. That is, in this case also we are getting the focal length of the concave lens as minus 45 centimeter itself. On repeating the same calculations for the remaining three cases, it will again give us the same focal length value, that is minus 45 centimeter. Now let us try finding the mean focal length in this case, that is mean focal length F is equal to minus 45 plus minus 45 plus minus 45 plus minus 45 plus minus 45 the whole divided by 5, that is equal to minus 45 itself. Or we can write the mean focal length f is equal to minus 45 into 10 raised to minus 2 meter. So we got the focal length of the concave lens as minus 45 centimeter in both the cases, that is by using the methods lenses in contact and lenses out of contact. Next, let us try to write the result of this experiment by using the observations we got. Then the result will be the focal length of the given concave lens f is equal to minus 45 centimeter. Before winding up this experiment, let me ask you something. What did you understand from this experiment? Yes, we understood that even though a virtual image is formed in a concave lens, we can measure the focal length of the concave lens with the help of the convex lens by using the indirect method. I hope you got all the concepts and the procedures we discussed in this experiment. For more interesting sessions, stay tuned with 90+.